Hi, welcome to College Algebra 1.8 Revisited. So last unit we talked about 1.8 and we did a lot of polynomial stuff, but that's because we were doing polynomials. This unit we've been doing rational functions, so that's why we're going to do 1.8 with rationals. So remember that 1.8 is all about inequalities out of our textbook. So now we're just going to do inequalities with rationals specifically. So we follow kind of a four-step process. You want to get one side as a zero. You want to combine everything else into typically one fraction. Then find the critical points. The critical points would give you zero on the top and on the bottom. And then we just do the sign test, where you make your number line, you test it, and you get those true, false, true, or false, true, false, stuff like that. So this first one, we have 2x minus 7 over x minus 5. The very first step is we want 0 on one side. So we can minus 3 to both sides, and we can treat that as a 3 over 1. And now our second step is we want to get only one fraction, or one rational expression. So looking here, x minus 5 is the denominator of the first one. And remember, when we talk about common denominators, we talk about them in terms of factors. So x minus 5 is one thing because factors are the multiplication property. So I'm going to multiply this fraction, this 3 over 1, by x minus 5 over x minus 5, which we see right here. Next, pretty naturally, we would distribute this 3, and then we also have to distribute this negative. So we get negative 3x plus 15, because this would be negative 15 and positive 3x. Distribute the negative, give me negative 3x and positive 15. We can then combine like terms. 2x and negative 3x gives me negative x, negative 7, and positive 15 gives us positive 8. Step 3, we need to find our critical values. So I'm going to set my instances of the numerator, so negative x plus 8 equal to 0, and instances of my denominators, in this case, x minus 5 equal to 0, and I solve it. Minus 8, divided by negative 1, we get x equals 8. Add 5, we get x equals positive 5. So those are going to be our critical values. And then we need to pick numbers in between those ranges. So I picked 0, 6, and 10. So we can then directly substitute into any instance. You can do it the original. I did it into this one right here because it's kind of easy if it's something's bigger or smaller than 0. But any way it works out, we get a true statement for 0, a false statement for 6, and a true statement for 10. Remember, this was equal to, so I would have closed circles on both of my critical points. Arrows pointed to where it's true. So I would get negative infinity to, this should say 5, I apologize, bracket, because remember, inequalities with the equal to are always with brackets on real numbers, union, bracket, 8 to infinity. Oh yeah, this is step 4, sign test. Apologize. Let's try another one. X minus 2 over x minus 3 greater than 3. So the first thing we want to do is get one side to 0. So let's subtract 3 from both. This 3, we can treat it as over 1. And I can multiply it by x minus 3 over x minus 3. And I can distribute this 3 to x and negative 3. So I'm going to leave my first fraction alone. Minus 3 times x, so 3x. 3 times negative 3, so negative 9. And then it's a matter of distributing this negative or keep, change, flip, however you want to visualize that. and then combining like terms. X minus 3x gives me negative 2x. Negative 2 plus 9 is positive 7. So then I can do negative 2x plus 7 equal to 0, as well as x minus 3 equal to 0. We're going to get x equals 3 right here. Here, minus 7, divide by negative 2, divide by negative 2, we get x equals 7 halves, which is the same thing as 3.5. So when I go to sign test this, my number line is going to have 3 and 3.5. So now we need to pick a value less than 3. So for the sake of argument, 0. A number greater than 3.5, so something pretty easy would be 4. And a number in between these two values is something like 3.2. Then I can just plug them into any inequality, either this one or the original. I often just plug it into the original. That way I can guarantee it's a battle of not making mistakes, but whatever works. So we have 0 minus 2 over 0 minus 3. Is that greater than 3? Well, 0 minus 2 is negative 2. 0 minus 3 is negative 3, which simplifies down to 2/3. 2/3 is not greater than 3, so that would be a false statement right there. Trying the next one, we're going to try 3.2. 3.2 minus 2 over 3.2 minus 3. 3.2 minus 2 is 1.2. 3.2 minus 3 is 0.2. 1.2 divided by 0.2 is 6. Is 6 greater than 3? That's a true statement, so I'm going to get a true in between. And then I can try 4. 4 minus 2 over 4 minus 3. Is it bigger than 3? 4 minus 2 is 2. 4 minus 3 is 1. 2 divided by 1 is 2. Is 2 bigger than 3? That would be false. So, also, I didn't have an equal to, so these are going to be open circles. The only true statements in between them. So my interval would be 3 to 3.5. Thank you for listening, and I hope you have a great day.